Statistics is a huge part of the secondary 3 core. You're going to see some problems, and they're really the easiest part of the core for secondary 3. But it's remembering the stuff we've learned that we've got to get down and remember. So, given this data set, make a box and whisker plot, and then we're asked what is the interquartile range. So remember, guys, you've got to know this interquartile range is Q3 minus Q1. So your box and whisker plot will give you all that information. Okay, so let's all get our calculators out. Everybody practicing this on your calculator, not just watching me do it. Because, guys, it is different when you're doing it yourself. So get your calculator. Go to Stat. Then in Edit. In List 1, you're going to put in the values that you're going to want in your box and whisker plot. Order doesn't matter because your calculator will sort them and put them from least to greatest for you. So put these in your List 1. I'll give you a second. So once you have those in, then you have to go to, if we want a box and whisker plot, so just one reminder, remember you can find which we don't need this for the box and whisker plot, but we're going to get to this later. And I don't want to have to, I want to show you. So you can go Stat, over to Calculate, and then we can go to one variable statistics and hit Enter, and it will give us a lot of information. Look, it'll give us X bar, which remember is the mean, the average. Look, it gives us sigma, which is our standard deviation. It gives us the number of terms n. It gives us our minimum value is 20, our Q1's 20, our median is 23, and our Q3 is 25. Our max is 27. So just remember that. Okay, so to make our box and whisker plot, you have to do second stat plot. See this y equals? We're not going to graph it in y equals, but we have to go second stat plot. Then you're going to go into stat plot, plot number 1. Make sure you turn it on. And then it says what type. So look, you can graph a dotted line. You can graph a bar graph. You can do a box and whisker plot with the outliers not in it. See, it has the outliers just thrown out as dots. And then we are gonna do our box and whisker plot with our outliers because it didn't say anything about throwing out the outliers. So you hit Enter. Now you hit Graph. But here's the thing: if you can't see it, it's because your window's not right. Isn't our highest value 27? So doesn't our window need to at least be at least 27? Let's make it bigger. So my minimum value I just did was 0 because there's nothing below 0 in these set of points. My max I did was 30 because my highest was 27. Now I hit Graph. There's my box and whisker plot. So I can draw that in, and then I can also just do trace. You don't hit second trace for these. You hit trace, and then you can scroll with your arrows left and right. So Q1's 20. Our median's 23, that's Q2, and Q3 is 25. So let's draw this in. So we have this box and whisker plot, and then it looks like this, right? So this whisker, our minimum was also our Q1, so that happens sometimes. So this was what, 20? What was our median, sorry?
23.
23, what's this? 25, and what's our max? 27. So then you'd list up here, you'd say, okay, this is Q1, this is our median, which is Q2, you can call it, this is Q3, this is our max. So, what's the interquartile range? It's Q3 minus Q1, so we'll do 25 minus 20, right? So it's ranging, our interquartile range is ranging between 5. There's a difference of 5. Questions? Because in this one, the minimum also happens to be Q1, quartile 1. So that just happens sometimes. So 20 also happened to be the median of the lower half. Does that make sense? Okay. Okay, so next problem. Describe the type of samples and surveys. So just a reminder, if you have an entire population, which population can be many things. It's not world population. Like, for example, our classroom could be a population, and a sample could be this table, right? Or a population could be the entire school, and our classroom could be a sample. You guys all understand that, right? This could be a population, and she could be a sample. So you guys understand that. Okay, so remember, there are different types of samples So once you have a population, you're going to take a sample. You're going to pick people by a sample. There's a random sample, which is usually the best. Systematic sample, also good. Convenient sample, and self-selected sample. So let's remember what each of these things are. Random sample is people are randomly chosen, right? Systematic is, there's a system. Every third person I'm going to choose, right? That's a system. And then there's convenient sample. Now, convenience means it's convenient for me. So if I say, I want to know how many people like movies, and I go to the movie theater, that's really convenient for me to ask everybody that walks out of the movie theater, right? Convenient for me, not them. And then self-selected sample is if the person selects to take the sample. So if you put it out in the newspaper, call in if you like movies. Then the people that actually care, they're self-selecting to call in, okay? So then once you pick a sample, then you're going to perform a study. There are different types of studies. There's an observational study, which you just sit back and watch. That's all you do. You sit back and watch, you observe. You do nothing to the sample. You just watch and make a conclusion. Then there's a survey. Surveys, you ask everybody the same question, or you do the same thing to everybody. Does everybody understand? And then a controlled experiment is you split the group into two groups. You have a controlled group, and then the other group, you perform an experiment on the one group and not the other. So this usually happens, like when they have come get your, we talked about, I heard it on the radio, come get your bunion removed, and you get it done free, and it's all for an experimental drug, new pain drug. So then they give people, and I know a girl who she went and got her wisdom teeth removed for free, and then they gave some people this new pain drug and the other people the placebo, which the people didn't know, and then they said they had to come back and make recordings of, I'm feeling this much pain, or I have no pain. So she got her wisdom teeth removed for free because this drug company wanted a controlled experiment done. Okay, so number 3, within how many standard deviations from the mean does all of the data fall? So first of all, don't we need to know the mean and then the standard deviation? So you guys try and find that for me because it takes me too long to do it on here. So type into list 1, type in these values, and then go to the one variable statistics, and I need you to give me the mean, which is x bar, and then sigma, which is the standard deviation. And then we can calculate how many standard deviations all these values fall. So what's the mean? Anyone have it yet? It's 4.6? And then what's the standard deviation? 3.0 then, right? Let's just go 3.0. Let's make it easier on ourselves. Okay, so our mean is 4.6, and our standard deviation is 3. So let's go one standard deviation above when we just add 3. Everybody? Yeah. So that's 7.6. Let's go 2 standard deviations above, 10.6. So these values fell within 2, right? Between 4.6 to 7.6, right? So then let's see below how many we had to go. So 4.6 minus 3 is, so this is one standard deviation below, it's 1.6. So then one more below, 2 would be at negative 2.6, right? Minus 3. Okay. So didn't all the points fall within 2 standard deviations? Are the other values falling below within 2 standard deviations? So all the data points fell within 2 standard deviations from the mean. This is my mean. We're all good with those? Okay. So it says a group of students GPA has a normal distribution with a mean of 3.2 and a standard deviation of 0.5. What's the probability that a student has below a 2.7 GPA? So remember, if you see the words normal distribution, it's the normal bell-shaped curve, right? You will see these on your final, and they're really the easiest ones. So you'll draw your normal bell-shaped curve in. We know this is our mean, so 3.2. So this is 3.2, it's our mean. Okay, let's go one standard deviation above. So we'll do 3.2 plus 0.5, so we have 3.7, right? So values that fall greater than 3.2 but below 3.7 are within one standard deviation above, right? Let's keep going. I hate how squished this is because then it kind of gets ugly. So then plus 0.5, so that's 4.2. And we could keep going, that's 2 standard deviations. Let's go for fun. 3 standard deviations. It's kind of getting messy here though. And I'm going to stop. Okay, let's go one below. So 3.2 minus 0.5 is 2.7. And that was one below, right? Okay, it says what's the probability a student had below 2.7? So let's keep going. This would be within 2 standard deviations and then 3. So then don't we know the probabilities for normal distributions? Yeah? You gotta have these down in your head. Won't 34% fall within 1 standard deviation above and below? Then remember, 2 standard deviations would be 13.5 that fall within 2 standard deviations. Well, in this section, right? Because really, that fall within 2 standard deviations is all of this, right? But you get what I'm saying, right? That fall in the section of 2 standard deviations. And then this is 2.35% fall in this section of 3, 2.35, and then left over is 0.15, right? Now add those up. You better add up to be 100%, and they do, so we've done this right. So it says, what's the probability a student had below a 2.7 GPA? So 2.7 was the 34%, right? So we add those up. That's below. So 13.5 plus 2.35 plus 0.15. 16%. Is everybody good with that? Okay, 16% of the students had below a fell below a 2.7 GPA. So it says, of 250 students, how many students would you expect to have below a 2.7? Well, isn't it 16% of 250 students we can expect? So to find exactly how many students, take 250 and figure out what 16% is. 250 times 0.16 is 40 students. Does everybody understand how to do it? Okay. Okay, now from here on out, my examples are coming off your packet. Okay, so problem 2 on page 59. Go to page 59, problem 2. This is really going to be your only review for arithmetic and geometric series and sequences, yeah. What? Right, so these examples are your only reviews before your final exam. These few problems that we're going to do together right now. Because we don't have time to do all of them, the rest of them. So we're going to just do a couple together. That's going to be your only hope to remember all this. So problem 2 on page 59. So you need to make sure you're paying attention. This is going to be your only review on arithmetic and geometric series. Okay, it says an arithmetic sequence begins with 4, 9, dot, dot, dot. So remember, sequences have commas, series are the same but just with plus signs, right? Series means just adding up the terms. So it says, what is the 20th term? So remember that the general formula for an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times b. Or else we could sit and list out up to the 20th term, right, if we got really desperate. But I'm going to do it this way. So we want a sub 20. So we don't want a sub 20. What's a sub 1? 4, and then plus, and then it was n, and it's 20, so we're doing 20 minus 1 times by the common difference. Now, what's the difference? Now, you have to make sure you do 9 minus 4. Does that make sense, everybody? The one that comes before the value above it. So wouldn't our difference be 5? Positive 5. So we're multiplying by positive 5. Then it's just simple calculations from here. A sub 20 is equal to, go. 4 plus 19 times 5. Our 20th term would be 91. Or we could have sat and added 5 up to 20 terms and then looked at the 20th term if we were really desperate, right? Everyone? Okay. Next problem. Page 59, problem number 4. Yes, this page is exempt, but like I said, this is your only review, so that's why we're just going over a few together. What's the missing term of the arithmetic sequence? So are we missing this? Now remember, if it's arithmetic, then this, then this, then there's a common difference is what I'm trying to get at, right? Common difference. So will this better be equal to this minus this? Isn't that true? Won't it be a common difference between? So this is a true statement. X minus 25 better be equal to 45 minus x. Then it's just solving for x. So we're going to add x to both sides. 2x is equal to, we add 25, right? 25 plus 45, right, is 70. So then divide by 2. So x is 35. The term in between is 35. So then if they said to you, okay, so what's the common difference here? Wouldn't it be 10? Right? Adding 10. Okay. Next problem, page 60, problem number 1. What is the 10th term of the geometric sequence? So once again, the general formula for a geometric sequence is this. So let's find the 10th term. Once again, if we were desperate, we could list out all the 10 terms and then look at the 10th term, but we're not desperate at this point. So we want a sub 10 is equal to a sub 1, which is our first term, which is 1, and then r is our common ratio. Remember, there's a common ratio. Ratio means division. You take the number that comes before the value above it. So you do 4 divided by 1 is 4. Is 16 divided by 4, 4. So our common ratio was 4 raised to the n, which is 10 minus 1. Let's type that in. Make sure you use parentheses. It's not, if this was like a 2, for example, since it's 1, it won't make a difference. But you got to make sure you type 2, like if this first term was 2, and then you do 2 times, and then parentheses. Make sure to raise it to all of that. So I'm just going to type it in, 1 times 4 raised to the 9th power. So our 10th term, a sub 10, was 262144. 262,144. Questions? So we would have sat and multiplied by 4 10 times and finally got here and then said it if we would have been desperate. Okay, next one. What could be the missing term of the geometric sequence? So this is something that you could very likely see, and really it's not that hard, so let's make sure we can do it. So geometric means if you got to know like geometric versus arithmetic. So we know this is not arithmetic, it's geometric, which means multiplication. Or common ratio. So I'm going to say, okay, I don't know what that is, so I'm going to call it x. Since it's geometric, there's a common ratio. So isn't it true that x over 5 better be equal to 125 over x? Now it's just solving. Now because there's an equal sign, we're trying to get x alone, and I do not want to have to build fractions. So, and there's a fraction on this side, and there's a fraction on this side, so I can cross multiply because we're solving. So we'll multiply both sides by x, well they divide out over here, right? Multiply both sides by 5, but they divide out over here. So we have x squared is equal to 125 times 5, 625, right? Square root it. X is equal to technically plus and minus, right? We take the square root of if we're trying to solve, we have to do plus and minus. What is it? So plus and minus 25. So it could be plus or minus 25. Don't forget plus or minus. So it's either plus or minus 25. So then if I said to you, so what's the common, or what are you multiplying by? What's the common ratio when you do 25 divided by 5? Which, right, is 5? So we're either multiplying by positive 5, so our ratio, what we're multiplying by is either 5 or negative 5, right? That was negative 25, we multiplied by negative 5, right? Okay, we're all good? Okay, that's all we're reviewing for sequences and series, because unfortunately we've had to spend so much extra time relearning stuff that we're not going to get to a lot of pages on the stage review. So these are the problems you can cross out. So today you need to be focusing on the statistics part, because it would be so dumb for us to not review this and then miss these when they're the easiest problems on your test. So you're going to do those pages today. These are the pages you can cross out. Yes, we did a few problems off of them today for practice to remind you and kind of help you not forget when you see some of that stuff in a week. Not even a week, a few days. 2 days. So you can now cross out all of these pages because we don't have time to get to them, unfortunately.